Hello, everyone. I hope you're doing fine. Hope you enjoy the conference. We're ready for our next speaker. Well, he'll be just telling us that his pet project got a new release. So that seems a bit dull, but before you laugh, please note that the speaker is none other but Sébastien Doeraene himself, a technical director of the Scala Center, EPFL's PhD, and I can personally assure you, a fabulous speaker. And the project is none other than Scala.js, which Sébastien is the main author of. So without further ado, please give a warm greeting in the confines of your homes to Sébastien. I'm gonna clap for you.
Thank you, Martin. Hello, everyone. I mean, I can't see you, but you can see me, so there's that. I'm very excited to be a part of Scala Love. It's my very first online conference, so hopefully this works fine. So I'm going to talk about what's new, what's better in Scala.js 1.0.0, and also what's next for the foreseeable future. First, I'd like to start with some dates about Scala.js. So in February 2013, we created the first commits. In February 2015, we released version 0.6.0, which was the first version that really took off, in a sense, the support for cross-project and shared things, plus good support for integrating testing frameworks and testing frameworks being able to easily cross-compile was a huge boon to the project, and from there on, it basically took off. The latest release in the 0.6 series was released in last January. That's the 0.6.32, and for all these past 33 versions, we have never broken backwards binary compatibility. So I think by now, Scala.js might be in the 0.6x branch might be the project with the longest streak of not breaking binary compatibility. And finally, in February 2020, we released version 1.0.0. So what's all the fuss about this big new 1.0? Why now, and what really did we achieve here? By the way, I'd like to remind everyone that feel free to ask questions via the Q&A feature, like at any time during the talk, and hopefully I'll get to answer during the talk. So if there's anything that you would like clarification on or ask further questions, don't hesitate. Some stats about Scala.js. So some people keep saying that Scala.js is a very niche thing that nobody really uses outside of pet projects. But at this point, there are like very good figures that in favor of showing that Scala.js is actually adopted. First, there are more than 100,000 downloads per month of the SBT plugin. At the last Scala developer survey for 2019, 13% of the responders said they were targeting Scala.js. And that figure is often criticized as being, well, yes, but the Scala developer survey is well represented in the open source library maintainers and all the people who have to cross-compile for the sake of cross-compiling. But actually, if we restrict the data set to people who also answered that they are only using Scala in their day job, that 13% is also confirmed for users of Scala.js. There are more than 3,000 members in the Git room, and as of 2 days ago, there were 127 libraries who had been published for Scala.js 1 already. And I see that we already got our first question. In your opinion, what might be advantages of Scala.js over TypeScript? Maybe I'll keep that for after the talk, since it's not directly related to the topic, but we can come back to it. Okay, so what's new in Scala.js 1? Well, not much. We actually focused this release on simplifying the language and the core tools, and on building strong and sound foundations for the future. Nevertheless, there are a couple things, and especially in regards to interoperability with JavaScript. I'd like to quote Antoine de Saint-Exupéry on this one. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And this has been our driving factor, I should say, for Scala.js 1 to remove everything we could get rid of and only keep what's absolutely necessary. So here are a few new things, the exciting stuff. So this is JavaScript code, as you can notice, and it's something that was awkward to talk to from Scala.js. So you can see that in this JavaScript code, we have this outer class, and then inside the constructor, I create a new class that I attach as a field of the object, which means that from the use side, I can first instantiate the outer class, and then I can instantiate the inner class of that specific object. In Scala.js 0.6, accessing such a JavaScript library is very awkward. But in Scala.js 1, we finally made it possible to declare a very straightforward facade type. So facade types, for those who are not familiar with Scala.js, is the way we give types to a JavaScript API so that we can then manipulate it from Scala.js. And so here we can very straightforwardly declare the outer class as a native class. And then inside, I have a JS native class, which naturally belongs to instances of outer class. And then I can instantiate the outer class from Scala.js and instantiate the inner class just exactly the same way that you would think. And if I switch back and forth between the JavaScript code and the Scala.js code, like the use side is exactly the same. So this is a new thing. We could not, in Scala.js 0.6, we could not have an inner class that was inside a native class. That was not possible. We can also do the thing the other way around. We can, from Scala.js, define new inner classes, new JavaScript inner classes that make sense from JavaScript's point of view. So here is, again, a JavaScript example where we have this function, greet people, that takes as a parameter a class. Because in JavaScript, classes are first class, well, so you can manipulate them as values, and then I can instantiate this class and call methods. And one way I could call these methods is by passing it this English greeter, which has a method greet, which displays something. But you might want to create greeters for other languages. So one thing you could do in JavaScript is declare a function that takes a message builder and returns a new class every time you call it. And the class that you return knows what is the message fund. So the way you can use that is you can make a greeter for create this message function, and then you can greet people with that class. And you can do that in English with hello name, in French, bonjour name, or in Japanese, name san konnichiwa, with the wrong stress, but. So in Scala.js 1, now you can also do that. So you can implement this make greeter method that takes here, I chose a format string instead, and I define a class within the def, and then I can return the constructor of greeter, which really means give me the class value and return the class value as a value. And then I can actually call this greet people method with the result of that thing, and it will do what we expect. So that was something that the Scala.js 0.6 compiler would let you do. but it would give nonsensical results at runtime because it was not meaningful to get the constructor off a local class or an inner class like this. And in Scala.js 1, it basically does what you expect it to. And you would think that is this like a very weird pattern that no one would actually use that, but in the JavaScript ecosystem, this is actually very common, especially in component classes for UI frameworks. This is a hypothetical UI framework, but that like illustrates the pattern. So you typically have in the JavaScript library an abstract class component with some abstract methods. And you have this register component method that takes some name to identify the component, and then it takes the class value of the component. And from Scala.js, what you could do is here you could create this local class that captures the value text here, so that I can easily create components that have a fixed text without every time having to redeclare my own class, etc., etc. Okay, that's about it for what's actually new. So let's move on to what's better in Scala.js 1.0 versus Scala.js 0.6. The first and most important thing is access to the global scope. So in JavaScript, what I can do, what I could always do, was declare a top-level function, inc, returns x plus 1, and then I can either call it with inc of 5, or I can call it with window.inc of 5. And here I'm looking up inc in the global scope, basically, and here I'm looking up the global object, the window, and I take this as a member out of it. So in Scala.js 0.6 already, we could simply declare a facade type for this thing, declaring an object global that says my members are in the global scope. I have a method inc, and then I can call it, and it prints 6. And in fact, the way that Scala.js 0.6 translates that is it translates it to basically window.inc. So it finds the global object, and then it calls every global scope member as a member of that object. Now in ECMAScript 2015, they added const, lets, and classes. And now they dissociated the global scope from the global object. There are things that are in the global scope, but not in the global object, which was not true before. So if you declare now inc as a const instead, then calling it like this prints 6, but trying to call it like this throws a type error because inc is not a member of window. So now if we do that in Scala.js 0.6, we end up with a type error because it actually translates that to window.inc. So in Scala.js 1, there was, it sounds like nothing, but it was perhaps one of the most important refactoring of the entire code base. But we made it so that access to members of JS global scope objects actually translates to accessing the JavaScript global scope as opposed to the global object. And so we fixed this, this huge gap in interoperability with JavaScript that we could not access the const, lets, and classes defined in the top-level scope because we were insisting on looking them up through the global object instead of through the global scope where they are not. Oops. So this is fundamentally at the language level, this is what's changed. So JS global things and members of JS global scope things used to access the global object in Scala.js 0.6x, but now they access the global scope of JavaScript in Scala.js 1x. And among other things, one thing we can now do is we can straightforwardly access Nodejs' special magic variables that are actually per module. So you can access require, dir name, module. You can reassign module.exports if you want. All from Scala.js, which was something you could not do before because there was no way to access those things because they were not available other than through the global big-ish scope that Node.js gives us. Totally different topic. It's not at the language level now, but really at the developing experience level. There is better debugging experience, at least for one thing. So let's take this small Scala.js project, like program, that intentionally throws an illegal argument exceptions, because we call check with -5, so this is going to throw. And if we try to debug that program in the developer tools of Chrome, for example, this is what we get in the console. So I see hello world is printed, and then I get this uncaught thing with nothing I can really read. Like I mean, at least it seems like it's an illegal argument exception. That's pretty clear, but where's the stack trace? No idea. And that was because in Scala.js 06, Java long throwable and all the Scala-defined exception classes, they are not true JavaScript exception classes. And so some browsers, some debuggers refuse to show a good debugging experience for those exceptions. Instead, in Scala.js 1, we made it so that Java long throwable extends JavaScript's error class, which is the superclass of all exception classes in JavaScript. So now all the exception classes of Scala.js indirectly extend the JavaScript error class, and that makes them true exception objects. And therefore, we get a proper uncalled Java long illegal argument exception with the message x smaller than 0 and the stack trace with links to the Scala files where things failed. So this is potentially much better, at least for the cases where you have to debug from a browser. Of course, I cannot fail to mention that we have better performance. This is a set of benchmarks from the Are We Fast Yet benchmark suite, if I remember correctly. And we are here measuring both fast-up.js in the light blue color and the runtime of full-up.js in the dark blue color against the same program run on the JVM. So we cross-compile our benchmarks and we measure the running time of Scala.js versus that of the JVM. So that means the JVM is for each benchmark is on this one line. So this is the JVM all the time on this line. Every time we have, so this here, the bounce benchmark runs 4.54 times slower in Scala.js fast ups than on the JVM. However, if we use full upt, you can see it's barely 16% slower than the JVM, which, given that we're running on a dynamically typed runtime engine, is quite remarkable. You can see that basically we never exceed like a little bit more than 3x, and often we are like between 1 and 2x ish of the running time of the JVM. So this is quite nice. We can also measure, again, for some benchmarks, we measure our running time against handwritten JavaScript code. So now the green bar is handwritten JavaScript for the benchmark. And here you can see that on 2 benchmarks, we are faster than handwritten JavaScript. And on 1 benchmark, we're basically only 1.27 times slower. So basically, Scala.js compiled code is very competitive against handwritten JavaScript code at this point. Okay, so what's next? What are we going to give you in the foreseeable future for 1 or 1.3 or who knows when? Well, let's start with something that might come very, very soon, possibly as soon as 1.10, which could be a few weeks away. Not making any promise here, but that's a reasonable expectation at this point. So one thing in facade types that we can already do, that we've been able to do since version 0.1 of Scala.js, is declare JS native objects and classes, right? But it's never been the case that we can define JS native vals or defs. And we are now implementing support for that. So if you want to access a member of a JavaScript module that is really a field of type int, you will soon be able to define it as an JS native val bar with a JS import annotation. Same for getters. So basically values that are like variables, so that their value can change. And also for functions in modules. So that will, for example, one member of the community was saying, "Oh, this is great because in my code I have this pattern here, which is that I artificially define an object logo banner with a JS import, which is actually a PNG file. And then what I do is I cast this object to a string. This is horrifying. It works. It's actually specified to work, but it's really ugly. And so with this new feature that you can have JS native vals and defs, we will be able to rewrite that in a much more elegant way, which is we'll have an JS native val logo banner of type string, and that way we don't need all these casts. The next thing, which will be for a bit further along the road, is module splitting. At first, so currently FastUp.js and FullUp.js generate one big JavaScript file with everything Scala.js within. And instead, or I mean, optionally, we will be able to split that across several JavaScript modules, giving the choice either to generate as many small modules as possible, which is good if you then feed those modules to a downstream JavaScript processing tool such as Webpack, because it can reload smaller files when things change incrementally. Or optionally generate as few large modules that have separate entry points. And this is typically good if you want to reduce the initial download size in a multi-page application, because every page would have their own entry points, and you would share the common codes across those modules and only use the page-specific code as well. Even further than that, for SPAs, for single-page applications, what you really want is asynchronous loading of the modules that have been split together. So let's take this example here of a very small hypothetical program with some UI that has an event that happens when I click on some specific feature of my UI. I get the input from some random HTML element, and I compute this foobar thing here, and then I put the result in some span on the HTML. So here, in the same file that when main is loaded, the entire application, we need to load foo immediately. There is no way around it. What we will probably provide at some point is, here it's a very tentative API, not in stone yet, where instead of immediately calling foo.bar, I can wrap some code inside js.async loading block. And that will, instead of returning an int, it will return a JavaScript promise of int, which you can then convert to a future to use for comprehension on it. And when the result is ready, use the span. The reason we would get a JS promise here is because we would asynchronously load a separate module that contains this computation. And in JavaScript, loading a module dynamically is necessarily asynchronous and will return a promise. So we have to return a promise of the computation. So that would mean that now in my main program, I have only the main program without foo, and foo will be moved to a separate module and will only be loaded when I start using the specific feature in my UI. The way we would translate that to JavaScript would be roughly like this. We have an async module 1.js file, which contains foo and its bar implementation, and then it exports one single entry point, which takes the inputs and returns the computation. So that's basically the code that was inside the JS async loading block. And in main, what we would do is here we would import this module, which is a dynamic asynchronous module import. And once the module is available to us, we call its entry point method, passing in the inputs, which will return a promise of the results, which we can then use to fill in the span inner text eventually. So I hope you're excited about this feature. I think a lot of people are actually. It's been asked zillions of times for Scala.js to be able to do that. So I'm very excited that we're getting closer and closer every week to be able to ship something like that. So let's let's get this through. With that, I will conclude my presentation, and I'm happy to take further questions.
There is one already. I can read it for you if you want to.
Yeah, go ahead.
All right. So Ruslan Shevchenko, whom I know, hi, asks, do we have some compatibility wrapper for Scala standard library, especially Scala.concurrency part?
So yes and no. I mean, the entire synchronous Scala collections, it's not even a compatibility wrapper or anything. It's you get the Scala standard collection inside Scala.js. For concurrent, I mean, parallel data structures, they are simply not supported because in JavaScript, you only ever have one single thread. There are web workers, but web workers have a distinct memory space. So they don't have shared memory, so you cannot implement parallel collections on top of web workers. So for parallel things, you'll have to use JavaScript APIs for that. The model of Scala concurrent data structures does not fit simply.
There's a follow-up. Is JS promise an instance of future, a Scala future, or any other model?
JS promise is its own thing. It's a JavaScript object, and in Scala.js, a JavaScript class is never a subclass of a Scala class, and conversely. However, you can, using toFuture, which I showed right here, you can very straightforwardly wrap a JavaScript promise inside a Scala future, and then you can use it as a Scala future.
Okay, I think that answers it. All right, we have like 1 more minute, but there are no other questions.
Well, maybe I can go back to the TypeScript question, which was asked in the beginning. So in your opinion, what might be the advantages of Scala.js over TypeScript? Pretty much exactly the same advantages that Scala has over Java. Because really the level of abstraction that TypeScript gives you is basically Java-like. And so if you think that Scala has any advantage over Java, then you can basically transpose those advantages from Scala.js over TypeScript. In my direct opinion, I think the most important things are immutability by default and immutable data structures. This is like the one thing that sets it apart, in my opinion. But then there is of course zillions of other things. I'm personally a big fan of implicit parameters. I think that, and path dependent types in Scala. I think those are two of the Scala specific features which I personally like very much. But I think one thing that can be agreed by virtually everyone is the immutability by default.
All right. I think we are done. The time is up. Thank you very much, Sebastian, for a fabulous talk.
Hope you enjoyed it.
Oh, we certainly have. Thanks a lot. Good luck with the future of Scala.js. Stay productive.
Thanks.